Welcome to today's Explainer, specifically put together for all you 8th grade learners out there. Today, we're going to uncover something genuinely fascinating. We're talking about the perfect symmetry found not just in geometry, but literally in our own lives and choices. We'll be looking at the math behind intersecting lines and how our source material connects this to the symmetry of our everyday actions. So, grab your notebooks, get comfortable, and let's jump right in. To kick things off, let's look at a quote from the book of Ecclesiastes. It says, "Two are better than one, for if they fall, one will lift up his fellow." Now, the Heroes Mark curriculum uses this exact verse to show how humans are designed to be in partnership. We're meant to lift each other up and mirror goodness. And honestly, this idea of pairs mirroring one another is the absolute perfect introduction to our mathematical concept for today. Just like we can reflect support to our friends, certain angles in geometry perfectly reflect each other too.
Section 1. Angles that mirror each other. The geometry of intersections. Let's get into it. Now, you might be wondering, okay, why does this actually matter in the real world? Well, these angle patterns are absolutely everywhere around you. Seriously, think about the roads you drive on at a busy intersection, the massive steel beams crisscrossing on a suspension bridge, or even the simple creases when you fold a piece of paper. They are everywhere. And once you understand how these patterns work, you basically get to act like a detective. You can start solving clues to find unknown angles without even pulling out a protractor to measure them. It's like unlocking a cheat code. These patterns save you so much time, and training your brain to spot them is absolutely crucial for crushing algebra and word problems down the line. So let's define our terms so we can start spotting these clues. Vertical angles are the opposite angles formed by intersecting lines. They sit directly across from each other at an intersection. Now, what's really interesting about this rule is that they are perfectly equal to one another, always. So if the angle on the left side is 50 degrees, the angle directly across from it on the right side is immediately 50 degrees too. Boom. No guessing required whatsoever. They are perfect mirrors.
But hey, what about the angles that sit right next to each other, side by side instead of across from each other? Well, that brings us to our second big concept, linear pairs. Linear pairs are two adjacent angles, meaning they share a side, that together form a completely straight line. And if you remember, the magic number for a straight line in geometry is 180 degrees. So their measures will always add up to 180. If you know one piece of a linear pair, finding the other is a total breeze. You literally just subtract the angle you know from 180, and there you go. You found the missing piece of the puzzle. So the crucial point here is making sure you keep these two rules distinct in your mind. Let's do a quick comparison. On one hand, we have vertical angles. They are opposite each other and perfectly equal. On the other hand, we have linear pairs. They are adjacent, right next to each other, and add up to 180 degrees. I want you to take a mental snapshot of these two distinct rules right now. Seriously, lock it in. Memorize the difference between the opposites that equal each other and the neighbors that add up to 180. Because once you have this down, you can solve almost any intersecting line problem that geometry throws your way.
Section 2. Solving the angle mystery. Let's solve together. Time to put our detective hats on. All right, here is our first mystery. Case number 1, you've got intersecting lines, and one angle measures exactly 72 degrees. So what is the measure of its vertical pair? I'm going to pause for just a beat here. Think about our rule for vertical angles and calculate the answer in your head. Got it? If you said 72, you absolutely nailed it. The answer is exactly 72 degrees. And why? Because vertical angles, the ones completely opposite each other, are congruent. They are exactly the same size. Great job.
Okay, let's dive right into this next one. Example 2. We have an angle sitting on a straight line, and it measures 115 degrees. So, what is the other angle sitting right next to it? Remember that mental snapshot we took earlier? We are now dealing with a linear pair on a straight line, not a vertical angle.
Let's walk through the super simple steps to crack this code. Step 1, we start with our straight line total, which is always going to be 180 degrees. Step 2, we simply subtract the known angle, which in this case is 115 degrees. And 180 minus 115 reveals our missing answer, which is 65 degrees. See how incredibly easy that subtraction step is? You're literally just finding the missing slice of that 180-degree pie.
All right, now for the ultimate challenge. Example 3 is a mixed diagram. We have two lines intersecting, creating 4 distinct angles. And I am only giving you one single clue. One of those angles is 110 degrees. Using everything we just talked about, can you find all 3 of the other missing angles? Think about it. We need to combine both our vertical angle rules and our linear pair rules to solve for every single missing piece here. Let's break down those 3 missing answers step by step. First up, we look directly across from our 110-degree angle. That's the vertical angle, so naturally it is also 110 degrees. Next, we look next door to the adjacent linear pair. It has to add up to 180, right? So 180 minus 110 gives us 70 degrees. Finally, we look across from that 70-degree angle to its vertical pair, which means the remaining angle is also exactly 70 degrees. And honestly, this brilliantly illustrates the way these interconnected rules just work perfectly together. From just one single number, you unlocked the entire picture. It's like a giant puzzle coming together. Section 3. Your homework challenge. Apply what you learned. You guys are doing great. Now it's your turn. So here is your homework challenge for today's explainer. Number 1, define vertical angles and explain why they are equal. Number 2, if one angle is 94 degrees, what is its vertical angle? Number 3, a linear pair has a 37-degree angle. What's the missing angle? Number 4, draw your own intersecting lines and label all 4 angles using the rules we just learned. And number 5, find all the angle measures when one intersecting angle is 120 degrees. I warmly encourage you to just hit pause on this explainer right now, grab your notebook, and copy these 5 tasks down. You've totally got this for sure. Section 4, Education Built on Morality, the HeroesMart Academy Philosophy. Let's bring it all home. The source material actually ties all of this back to the book of Romans, chapter 8, verses 6 through 7, which promises peace of mind to everyone who keeps his or her mind spiritual. The curriculum emphasizes that this isn't just some ancient text. It's meant to be a highly practical guide. Their philosophy essentially argues that when education is paired with spiritual growth and a genuine focus on goodness, the end result is an incredible, lasting peace of mind. Which leaves us with a really provocative final question posed by the curriculum. What is the point of being highly educated, of knowing all the math and science in the world, if you continue to make choices that hurt yourself and others? The HeroesMart philosophy argues that education without morality is just empty. But when you combine a brilliantly sharp mind with a compassionate, morally grounded heart, they reflect each other perfectly. They create a beautiful, perfect symmetry, exactly like the angles we learned about today. Thanks for joining me on this explainer, and I'll catch you next time.